Ladies and gentlemen, you know what a beautiful thing is about recording these videos online is if you go through and do a whole example and then your computer blows up and then you lose your example, so you have to start it all over again. You'll have no idea, but that's what just happened to me. So I'm going to start this example again and let's go through it. In this example, I need to solve the triangle. And if you can hear the TV, can you guys hear the TV in the background? If you can hear the TV in the background, it's because my dog over there really, really likes to watch TV. His name is Dilly. You may have seen him in some Google Meets. And he's locked right into that television at the moment. So I'm sorry if you can hear it in the background. But, anyways, so we need to solve this triangle, which means we want to find all angles and find all side lengths. So here we go. We're going to find all the angles and find all the side lengths. I know that angle C here is 27. I know angle B is 90 degrees. That's what that means. I don't know angle A. Is there a way for me to find angle A that is not trigonometry? Like a quicker way to do it? Well, there is. The last example that we did at the end of the last video, the sum of all angles in a triangle equals 180 degrees. That means when I add them all together, I should get 180. So if I take 90 plus 27 and plus A, I should get 180 degrees. So 90 plus 27 is 117. So to get A, if I subtract 117 from 180, A will equal A will equal 63. So I know that this angle A is 63 degrees. Now, there's a way to prove that to you using trigonometry. I will do that at the end of the video. But let's now go through and take a look at the side lengths. So I don't have, let's call this side length here A. I don't have that. And the longest side of the triangle, the hypotenuse, is B. I don't have that either. Let's find them. So to find side length A, here's a little tip. Always use the numbers that are given to you. Do not use the numbers that you found, just in case you made a mistake. Okay, so in this case, I'm going to use 27 degrees and I'm going to use 6 because those were given to me. So if I use those to find A, what I'm going to do is I'm going to take, okay, 6 is the opposite to angle 27, and A is the adjacent to angle 27. So for SOHCAHTOA, I have the opposite, I need the adjacent, so I'm going to use the tan. The tan of my angle, 27, will equal the opposite, which is 6, divided by the adjacent, which is A. I don't know what it is. Now, we did examples like this in the first lesson. If I write the tan of 27 over 1, I have a proportion, so I can just cross multiply and divide. I take 6, multiply by 1, and divide by the tan of 27. 6 times 1 divided by the tan of 27. When you're doing this calculation, again, make sure your calculator's in degree mode. Of course, 6 times 1, guys, is just 6. So 6 divided by the tan of 27. If your calculator's in degree mode, you should get 11.77 and change. Let's just round that to 12. So side length A is 12. Let's look for side length B now. Side length B. Okay, let's get rid of these. I know that the angle 27, if that's the one I'm using, 6 is still the opposite to angle 27, but B is the hypotenuse of the triangle. So I'm going to use opposite and hypotenuse, which means I'm going to use sine. The sine of the opposite, or sorry, the sine of 27 would be the opposite, which is 6, divided by the hypotenuse, which is b. Now, 6 and b look very similar in this case. Just be careful with that. Write the sine of 27 over 1. And again, you have a proportion. You're going to start with 6, multiply by 1, and divide by the sine of 27. So 6 times 1 divided by the sine of 27. This should be different than dividing by the tan of 27. 6 times 1 is just 6, divided by the sine of 27. And I get a bigger number, which should make sense, 13.21 and change. Why does it make sense that it's a bigger number? If I round, it's 13. Well, it's the hypotenuse of the triangle. So it should be bigger than one of the legs. And so I have found all of the side lengths. I've found side length A, side length B, and I found this angle as well. I found angle A. I should have made that actually a capital just to be consistent, capital A, okay? Now, let me just do some quick trig to prove to you that 63 is the right angle. If I were to use, like, let's say side length 6 and side length 12 in a tan function, the tan of my angle, I'm going to try and prove to you that 63 is my angle. The tan would be, so 6 is the adjacent, 12 is the opposite. So it's going to be opposite over adjacent, which is, I'm actually going to use the rounded 12 number, 11.77 and change, divided by 6. So if I take the second function of that, second function tan of 11.77566303 divided by 6, I get 62.9 repeating, which is, if I round, 63 degrees. Boom. So I did it right. Now, this little part, guys, you do not have to really worry about. I'm just doing that to prove to you that we did it right, and that our tan functions work, okay? You have to worry about finding side length A, side length B, and the other angle in this case. Again, I hope that all makes sense. I'm going to give you some examples to do. Ask me any questions that you have. Thanks.